Okay.
All right. I know Nolan has to head out, but Nolan's one of the original primary authors of the Open Book Genome Project, and mentioned he would be happy to answer questions over Slack or over email. Nolan, thanks for showing up. Sorry about the timing.
Yeah.
Sure. Yeah.
So
No
much.
worries. I'm a man of many hats. I'll wear the-
Yes. All right.
All right. See y'all later.
Cheers. And I think Teo is also going to be joining us at some point, so we can loop Teo in when the time is right. Okay.
Great.
I wanted to ask, would it make sense to start with questions, or would it be appreciated if I gave kind of a quick tour of where resources are located and kind of the state of the project? Which would be a better place to start?
For me, I think a quick tour, and then I also have kind of like the higher level question of how much has this been socialized within the archive? Like, is Brewster like, fuck yeah, go ahead? You know what I mean? Like, where are we with implementation of this on archive.org? So yeah.
Okay.
Please.
All right. So for the Open Book Genome Project, I think the kind of skipping ahead, the biggest question that I think will be had internally is, how would the derive integration work? So what I've heard from Brewster is, sure, yeah, go ahead, make the book genome files and items, create your own pipeline. But I think Brewster tends to prefer things not being within derived processes when possible. He likes us setting up our own external pipelines, which may create additional headaches for us here. But it seems like Jude is very optimistic about the Book Genome Project being incorporated as a scribed serverless derived process. And in fact, there's information that the Book Genome could potentially generate that could make the scribe process a lot easier, including like fetching the scan data page assertions right away and having that go into the process rather than us having to reverse engineer. How do we take an item that is missing a scan data and add it in with some sort of confidence? Okay, so Brewster knows about it. Jude is very excited and on board, and seems to be willing to do anything to at least get the framework in place. But I think what we're going to all quickly realize on this call is that there isn't much sophisticated going on here. I think the advancement is that there is a pipeline that can read a book and come up with some insights and upload it. And Nolan put a ton of work into making sure that all of this happens and doesn't like break items or pollute them. And that's really the advancement. There's no machine learning. There's literally nothing fancy going on. The code is far less sophisticated than Jake's IA tool, which actually has to deal with a lot of like IA item stuff. So why don't I move into the Open Book Genome Project website for a second and just give an idea of what assets exist. So the reason that we created this thing at all is that there are people in the community who would like greater access to our borrowable books, at least in an insight form. And there are insights that they would like to see that we may not be prioritizing, and they want some way to have an effect on the derives that are being run. So like grade level might be one example, but there might be an organization that is trying to do a research project and is trying to figure out how many of our books have like biomedical terms. And if there's a way that they could run that sequencer and then have a research set that is generated that we think would be valuable, then it gives us a way to kind of extend the scope of our book processes. Cool. So the first thing to kind of show off is that we have a GitHub project called the sequencer. And that's more or less the only asset that we should care about. So I'm going to open that up in a tab. And then we have a guide here, this freely available to the public link. let's see, is that the right one that I want? Oh no, a batch of books. So if you click batch of books, this is a document that I had created quite a while back for OpenAI, actually, when they were just starting to do GPT and GPT-3. Sam Altman, I think, and some of the people from the OpenAI team had asked whether we have a collection of books that they could use to train their model. And the collection that I was able to put together was a set of unrestricted books. And so here's a set of 800,000 or so unrestricted or public domain books that researchers can use to test the Book Genome Project, and kind of explains our processes for downloading materials. So not going to be as relevant for us, but it's good that all of you know that there is a data set here in case someone wanted to contribute. Okay. And then the next thing that I'll show is the Google Colab. Did any of you have a chance to open up the Colab doc? That's great. If you shake your head no, that actually makes my job a lot easier, because presumably we're all on the same page here. So the code itself, which is on the Open Book Genome Project /sequencer, has a directory called BGP, which is where all of the main code lives. And I'm going to try to keep this out of the technical weeds, but I think it's good from a very high level just to understand what's going on. So if we click the init file, that's where this whole library begins. If someone were in Python land and said from like import the BGP project, then the main code that would run is in this init. And what happens in this init is we pull in a bunch of core modules and processors that can do things like URL extraction, word frequencies, page type detection, copyright page detection, things of this nature. So it basically just pulls in all of those modules, and of course you could write your own. And then it has some special caching or memoization functions. The purpose of these is that some modules will require XML, which is a little bit more expensive to pull down, because we have all of the XML tags rather than just a raw text document. But some modules might require, for instance, page numbers. That's how we would know, oh, the table of contents is page 12. We wouldn't know that just with the raw déjà vu plain text. So this ensures that when we pull down a file, we can run lots of different modules, and we only have to fetch it once using Jake's tool. We have some utilities here to pull down either a single book or many books at a time. And kind of the fun thing is we're actually injecting this functionality directly into Jake's IA tool. So we basically have a way of getting the items XML and plain text using this memoize ability, so that once we fetch the text, we're not doing it multiple times. And then we can, in all of our modules, just choose the right data for that module. Okay. Then we have this thing called the sequencer, which sounds a little bit more intimidating than it is. The sequencer's job is to take a sequence, which is basically a set of instructions for what we'd like to run. Maybe a sequence is first come up with n-grams, then come up with a copyright page detector, and then come up with an ISBN identifier. That would be like a sequence. Those three things you want run. And you get to basically provide that as a pipeline. And then we basically loop over all of the jobs in that pipeline. So the first one maybe would be like the ISBN detection, and it would run all of them. And then when we're done, we can save it to an item if we want, or we could save it to disk if we want, or we could upload it to an item. Everyone kind of on board so far? All right. So then I'm going to skip down to the bottom here. We have this thing called the default sequencer, which is kind of an out of the box. If you wanted to run the Book Genome Project on an item, then you literally call bgp.getItem, like the same kind of magic as Jake's tool. And then you say, you you get a default sequence and you say dot sequence, and then you give it the item and you're done. It spits out the genome. So I'll jump back into the code in a moment to show what's actually going on when we create a sequence, because I think that is going to be really useful for anyone working on this to understand. But why don't I get out of the weeds now and we can actually see what this thing is generating, how it works. And to do that, I'm going to jump into the Open Book Genome Project sandbox. This is a Google Colab. Any of you can jump in here and try the library and install it out without having to install anything on your machine. So it's just point and click. So the first thing that we would do is we would install the library, which has already been done for us. And then here we're going to say import the Book Genome Project library and specifically get the IA tool from it. But this is the special IA tool that we have extended with the ability to fetch books easily. And so we run that and it does a little bit of work. Oh, I guess I need to probably reinstall this. This might take a few seconds. Well, while this is reinstalling, because I guess it hasn't been used in a while, I can talk about some of the deeper internals of what this default sequencer means. Sorry, it's not as coherent as I would like, but we'll go back to it. So I think the important thing to know about the Book Genome Project and sequencers is that certain tasks operate better on different files. So you can imagine, let's say I want to come up with a page type detector. Then the logical unit for a page type detector is an entire page. Whereas if I wanted a n-gram checker, then the logical unit would be a word rather than a page. So in the case down here, we have these things called processors. So we have the hierarchy here is that we have a sequencer, which is doing all of the work. We have a pipeline that is running the sequencer. And then we have processors, and processors have modules. I promise that's all we need to know, is that we have the sequencer. The sequencer is defined with processors, and processors have modules. One example of a processor might be a page type processor. And given a page type processor, there are lots of different modules that we could run. For instance, we could run a copyright page detector, a ISBN page detector, a table of contents page detector. And what the processor is responsible for doing is just walking over that unit being a page. So for the page type processor, it'll fetch down the XML, and then it will loop over all of its modules, and it will give it one page at a time. And then each of the modules will run so that we don't have to run this thing like 20 different times. That's really the purpose of the processor. The processor defines how we process the book. So it might step one page at a time over full text. It might step one word at a time over XML. And then if we actually take a look at one of these processors, we'll go into modules, and then we'll type let's see, not init, we'll go into the terms. We can see one example here, which is we have a full text processor, and the job of the full text processor is to get the déjà vu of a book, and then run a module on every page of the full text. So in this case, the full text processor might run a reading level module. Oh, actually, I misspoke. The full text processor gets the entire book in one go, and it just runs through the whole book. Whereas the page type processor or the n-gram processor deals with chunks of words or an XML page at a time, etc. So that's more or less how the whole thing works. You have the sequencer, The sequencer gets defined with processors. The processor is responsible for dealing with a specific, like either XML and full text, a unit of that book, like a page, and then the many modules can be assigned to each processor. All right, so it looks like we are installed here. And then if I run this again, hopefully it doesn't break. Okay, cool. So we said from BGP import ia.getItemGoodie, and here it's shown us that we have successfully fetched the goodie item. So we can also do this in bulk by saying an IA query. In other words, I want to sequence all of these books. So we would say ia.getBookItems, which is something that's been added, which wraps the IA search. You provide it with a query and then a limit, and then it fetches all of the books that you can then sequence. And then sequencing a book, by default, you can just import the default sequencer or the minimal sequencer if you just wanted to like detect ISBNs, for instance. And then it will pull the book down. We already have the book from above. That's what this is. This comes from the previous step. And here it says, great, we have successfully sequenced this book. And then once you have the sequence, you can say genome.results, and it will show you, here it's showing you all of the keys that are in the object. So this has successfully fetched 2 grams, 1 grams, URLs, reading level, copyright page, back page, and metadata. And then if you'd like to learn more about the sequencer and how it works, there's quite a bit of documentation that you could either show or hide. And then if you wanted to create your own custom sequencer, then here's an example right here of one where what we do is we say, I want to pull in the sequencer. I want to take the page type processor, which is going to take 1 page of XML at a time. And then I want to run it through a single module, the copyright page detector module. And so I would then create my sequencer, which has a page type processor and then the modules that go in it. And then if I were to run this new page type detection sequencer and then sequence it, then it would give the results of here's the copyright page, here's the ISBNs that were found, here's the amount of time that it took, etc. Okay. And then if you want to see the results of a default sequencer, let's just run this really quick, just so everything's up to date. Okay. Then here we can see that it has a reading level. It's come up with n grams for this book, in this case, Goody Two Shoes. And so we see Goody Two Shoes, Renowned History, Marjorie Two Shoes, which is super useful if we wanted to augment our subjects, for instance. And in this case, there's no copyright page that was detected. And then there's a method to save or upload should you want. And then so here's kind of a minimal example. You just import IA in the default sequencer. You say ia.getItem. Now we have a book. The book gets passed into default sequencer.sequence. And then here you have a genome that's populated with data. And you can either run genome.results or genome.upload or genome.save. And this is ends up being a JSON file called bookgenome.json. So if you wanted to do this in a batch, then the only change that you would make is you would import the default sequencer, you would construct a query for archive.org, you would use ia.getBookItems instead of ia.getBook, and then you would loop over those books, and for each book you would sequence the genome. So pretty simple. However, there is a mechanism for doing this at like a much larger scale using concurrency and automatically uploading things to the archive. And that is done in a file called pipeline.py. And I think that's probably a topic for outside of this call, because I think it ends up getting a little bit more in the weeds and technical than may make sense right now. But this file is documented really well by Nolan in the README. So right here, using pipeline.py. Right now, it doesn't yet just take a archive.org query, but if you were to take all of the items from like an advanced search.php and just save the JSON, then if you had a file that looked like this, one entry per line, identifier colon item, then you could take that file and run it in the pipeline, and the pipeline would automatically know where to start, where to finish, know how to retry. You can determine whether it uploads to archive.org or not. And this part is like really janky, like really, really janky. But the way that the tool gives us analytics without us having to work very hard is after an item is sequenced, we just touch a file where the file name gives us an idea of whether it failed or succeeded. And then if an ISBN was found, we just touch that into an item with the identifier and the ISBN in it. And this allows us to very easily say, do a grep or like a find for all files in this directory that have ISBN underscore something, or show me the number of files that failed, like update underscore failed. So this is not meant to be sophisticated. This was a really cool idea that Nolan had just to get us at a point where we could say, show me every single book that had URLs in it. All you have to do is grep for URLs underscore not zero. Anyway, that's really the crash course of the whole thing. And if we wanted to us.archive.org, if we wanted to try this out, then right now on oldev1.us.archive.org in opt, there's a directory called sequencer, which is all set up. And within Docker, we have, I believe, I don't know if it's running right now, but typically we have a sequencer. Let's see if we have a, yeah, so we have a Docker compose file here. So you could say Docker Docker compose on, actually, we can probably just run this Docker compose on, yeah, it's going to be what we want. Oh, and then I guess. No, I guess I don't need the YAML. Docker compose up. Do I need the container name? Oh,
I think you just had it. You just had up in the file name in the wrong order. Maybe should be like docker-compose space up space docker compose dot YAML.
Let's give that a go. Thank you. Why is it not like that? Let's try to export it.
I think you want to export the environment variable and then add a, how do you say it in English? Semicolon between the Docker compose up and the environment variable. That's, yeah. There you go. Oh, you're missing a file.
Composer, I think.
But what is the missing file?
It's talking about a different, it's talking about an open library file, so that it's not really helping us. Let me see if I do, oh, compose file, that's what it is. Compose file. Thank you. Let's go. Okay, sorry. Volume name is too short. Sorry, I'm not going to spend more than 20 seconds on this, otherwise it's... I guess I can do that. This might have to build, but if you do a Docker compose up, then you'll have a container that you can just shell into. And then once you're within the container that has Python, and the only thing that you'll need to do is run an IA configure so that the sequencer has your keys. And then it should be relatively easy to add a new processor. And the way to do that would be in BGP modules terms. Any of you want to give an example of what you would like to see? Like what module would you want to see?
I want to find potential publication dates on the title page,
On the title page.
or I guess the reverse of the title page, the copyright page, if we're calling it that.
Okay, so the good news is we currently have a copyright page detector module. So the copyright page detector module can look for a few different things, like the copyright, the word copyright, or the copyright symbol. And then we also have, let's see, yep, go ahead.
It finds the first page with the copyright symbol.
Correct. In this case, it has a match limit of 1. So you could configure this to have any number of matches. If you wanted to find like chapters would be a good example. Find me all of the pages for chapters, chapter headings in the book.
So what if like the copyright page is mostly at the beginning of the book, maybe at the end. What if with OCR we could not correctly extract the copyright sign or the word copyright, and it finds the word copyright somewhere in the middle of the book in the actual text? Do we have any checks for that? I mean, overall, I think we don't really have data on copyright checks, but for example, on ISBN identifiers, do we have any idea what the rates are of bad extracted information and good extracted information?
We do. So Nolan, I think, checked. Wow, sorry, my phone keeps ringing. Nolan checked, I think, 200 different books, and manually confirmed on all of them that either the ISBN number had been successfully extracted or that there was no ISBN. And I think that there were maybe 2 or 3. Sorry, I'm on a call right now. Okay, so there are a few cases where like it gets tricky because we have an ISBN that's referring to, like Alexa said before, and paperback versus hardcover, or also edition level stuff for volumes, I think can get a little bit more tricky. But we didn't find any cases where the word copyright was mentioned a bunch of times, but not on but then there was like in the copyright page in the back. And the reason I presume that isn't the end of the world is that even if the copyright page were found, it would just say that there's no ISBN found. But otherwise, the copyright page kind of has strength added to it when we're able to detect either an LCCN or an ISBN with it. And then the way that we make the ISBN even more accurate is that Nolan's check looks both on the front page and for a back page. And so you could set parameters based on whether you have matching ISBN numbers in those locations. So if we wanted to have a really rigorous system, we would find the copyright page, which we could choose to or not to assert in the scan data. And then beyond that, we could decide whether to upload the ISBN to the metadata if, for instance, our stringency plan is that both the copyright page and the back cover have the same ISBN. So all of this is configurable. And I think before we do really use this in scale, we should configure it. but at least for our case, the only like policy questiony type things that might come up for the books that we ran, the 200,000 we ran on, are that we were adding ISBNs because we confirmed that they were both on the copyright page and the back cover. That's kind of how we were operating. So in this case, we have a thing called the keyword page detector module, and that can be used to build any type of keyword page detector module, such as copyright page or back page. In this case, we already have the copyright page detector. And so here, the copyright page detector has basically, when we have identified a match, then run these extractors. And here, the only extractor that we're running is ISBN extractor, but we could easily add another one onto the list, which is for date.
Right. Okay, great.
Yeah. There isn't a whole lot of like very sophisticated work happening here. It's just a end-to-end implementation of a thing that can run with Docker so that it could easily be added into our derive process. But like the work that Merline has been doing with OCR is like infinitely more complex. And I was actually hoping that like Merline would be one of the people who is excited about adding things into this framework, in and outside. As long as it happens, I'm cool with it. Was this helpful at all?
Yeah, absolutely. You mentioned that the ISBN finder has been QA'd on 200 books. Have other aspects of this been QA'd, like the grade level thing is one that comes to mind, right? Like if I wanted to say these books are appropriate for these age groups, is this reliable enough? Do we know that yet?
I would say that I'm unsatisfied with the current grade level code that we have here. I think it's a huge opportunity. The things that are top of mind for me in terms of where I think we could be getting a lot of value are in improving the reading level, and then also having a way such that when we find URLs, they automatically get submitted to the Wayback Machine. Because if a book is going to mention a URL, that's probably a good indicator that it's being cited, right? Mm-hmm. And then page types are another really important one, such as if we could come up with not only the copyright page or the table of contents page, but also come up with like chapters, then that could be an interesting opportunity for previews, like definitely glossary, bibliography, etc. Those page type detections I think would be really useful for us. And then I'm sure there would be lots of other good ones. 3 grams have been proposed. 3 grams that show up 5 times or more, which would be like a contemporary science manual or something. If that's referenced a bunch of times, that's like an extremely high signal of what the book is about. Mm-hmm. The only reason I could see that like not working well is if it was like Alexis Rossi says, right? Which would still be like, all right, well, like, yeah, this is an authoritative.
Alexis talks a lot in this book.
or like if Alexis says it, you better listen, like it's right. Yeah, those are the key ones that are in my mind, but I'm sure that there's a lot of other things that we could do. Date, publisher, some of the fundamentals, but we would have to come up with a good template or formula. And that might be a place where some sort of classifier does make sense. We use the book genome to first do a sweep and identify the page. But once we are pretty sure that we have the copyright page, then we could run a classifier on that and determine, you know, what is the date and what is the probability associated with that date.
Yeah, we're noticing a lot when we go to make things public on January 1st that are old, that people are asserting the wrong dates or choosing MARC records that have the wrong dates. So we think it's a first edition, but it's really not. You know, those kinds of things. So having some way to check if we think our data is correct or not would be really helpful.
This is data from the Internet Archive books collection.
Yes, although sometimes it came
interesting.
from our own scanning process. Sometimes
Right.
the library that donated the book gave us the records, like it can come from different places, but this is stuff that we think is correct. And we are trying to make decisions on that are, copyright decisions. And we're finding out that in many cases, it may not be correct. So having some way to find those dates and figure out which ones are likely to be right versus not right would be very helpful.
It would be interesting to just do a search, since we have the full text, for the year and see if he even shows up in the book.
Yeah.
Like how
what
many
I'm
years?
thinking is like if you see that it's the right year, that's great, but that doesn't tell me that they chose the right year, because what usually happens is the copyright page will say copyright 1926. Next edition was 1935. Next edition was 1954. The next great. So I'm actually looking at the 1967 edition of a book that's original copyright was 1926, and someone chose 1926 at some point. So just because 1926 is there doesn't mean it's right.
Yep.
Yeah.
And that's a difficult challenge. That's
Yeah,
a real
good times.
challenge. This hopefully gives us a framework for dealing with it, but I have to stress again that, like, as you can see there, this is not very sophisticated code. It's just meant to be a framework that runs, and we have it in place now, and now people can be completely unsatisfied with it, and that's the impetus for people to add things, right?
Yes.
Yeah.
Okay, so you're thinking the grade level is maybe not as accurate as you would like it to be. Are there other things it does here that you feel like are not very accurate? Whether that's finding the copyright page, for example, or some other smaller thing that it's doing.
The copyright page detector and the back page detectors have seemed to have been working pretty well. I wouldn't be comfortable, saying that it's like 6 sigma, that it's, that we have that type of accuracy. But I think if there are, I would want to know very carefully what the things are that we're concerned about. Like, is it actually dangerous to us to assert a copyright page that is wrong? I don't think so.
I think it's dangerous to, for example, with the ISBN codes, even if you find the same ISBN codes on the first and last page, so to say, not exactly the first, but you get what I mean. There is cases that, the same letter type is used on that first page where you find the ISBN, and the last page you find the ISBN, and OCR has problems with certain letter types, which would then give you the wrong ISBN twice. And if that gets put into the item on Internet Archive, we could filter out books which we think we have, but we actually don't have, because
I'm not quite as worried about that, because in the code we are doing a checksum on the ISBN, and we're validating the ISBN itself.
Right,
so
right.
It would not only have to be wrong on the front page and the back page and be wrong in the same way, but also be wrong in such a way that validates the checksum.
Yeah, no, that sounds good.
Yeah.
Cool.
And if there are things wrong, I have no interest in defending it.